neurosymbolic reasoning is really the objective of these initiatives that Fei-Fei Li is going toward.
We can infer, we can make certain predictions about how the world works because we live in this 3D world.
Spatial intelligence is going to be a key component for everything surrounding embodied AI, robotics.
So much of what we understand in terms of language models, large language models, were emergent properties.
Hey, what's going on, everybody? Today is October 15th, 2024. You're listening and watching the Daily AI Show live, and today we are diving deep into spatial intelligence. What is that? Is it different than artificial intelligence? What does it mean? Who is Fei-Fei Li? We're going to get into all of that today, and with us today, we have Junmi, Andy, Beth, and I'm Brian. And this is a really fun topic. I'm really excited to get into this one because it's just a different way to look at how to use AI. So we're going to talk about how it differs from what would maybe considered 1D, one-dimensional language models. There's some really good information about that. We're going to talk about, what they're trying to achieve through their company. And when I say they, I'll explain who that is, through World Labs, which, by the way, is only like a month and 2 days old. So when we're talking about this, I mean, it's some of this stuff, not the spatial intelligence is a month old, but a company from Fei-Fei Li and others is. So I think, honestly, just to get this conversation going, guys, I thought it'd be interesting. I have a couple clips keyed up, just a minute or so, from a recent podcast that you guys might have watched as well, called The Future of AI is Here. It's from A16Z. And it says, Fei-Fei Li unveils the next frontier of AI. Not only does she explain who she is and what her background is, but they do a good job at another clip of explaining what, in fact, spatial intelligence is. So maybe we'll start there and then dive in if you guys are cool with that. And since this is my first time sharing, let's make sure I do this right. As we said on this show, guys, we just moved over platforms, so some of this stuff is a little bit newer to us, but let's get this pulled up here really quick. Okay, fantastic. Worked just fine. So the first thing I wanted to do is just explain a little bit, and hopefully this will do it without running a commercial. I wanted Fei-Fei Li to explain who she is. Let me make sure I'm not. Let's go back to regular speed here, and let's go ahead.
And I come to AI through a different angle, which is from physics, because my undergraduate background was physics. But physics is the kind of discipline that teaches you to think audacious questions and think about what is the remaining mystery of the world. Of course, in physics, it's atomic world, universe and all that. But somehow that kind of training thinking got me into the audacious question that really captured my own imagination, which is intelligence. So I did my PhD in AI and computational neuroscience at Caltech. So Justin and I actually didn't overlap, but we share the same alma mater at Caltech.
Oh, and the same advisor at Caltech.
Yes, same advisor, your undergraduate advisor, my PhD advisor, Pietro Perona. And my PhD time, which is similar to your
Okay, we're going to pause it there, and because she does go into more detail about like her background, but I wanted everybody just to hear kind of a little bit of her talking about how she comes in from a physics background. It's really, really interesting. I highly recommend this podcast. If you're interested in this topic, when we're done here, go watch the 48-minute interview that they do here, because you will get a whole other understanding of it. We're going to kind of touch on it today. But let me skip forward here really quick to the 20-minute mark, because that's where we're going to get a little bit more of a definition, and then we'll jump into the conversation here. So right about here.
Into this, which is, so, you're starting this company, World Labs. Spatial intelligence is kind of how you're generally describing the problem you're solving. Can you maybe try to crisply describe what that means?
Yeah, so spatial intelligence is about machines' ability to perceive, reason, and act in 3D space and time. To understand how objects and events are positioned in 3D space and time, how interactions in the world can affect those 4D positions over space-time, and both sort of perceive, reason about, generate, interact with, really take the machine out of the mainframe or out of the data center and putting it out into the world and understanding the 3D, 4D world with all of its richness.
So to be very clear, are we talking about the physical world, or are we just talking about an abstract notion of world?
I think it can be both. I think it can be both, and that encompasses our vision long term.
Yeah.
Even if you're generating worlds, even if you're generating content, doing that positioned in 3D with 3D has a lot of benefits. Or if you're recognizing the real world, being able to put 3D understanding into the real world as well is part of it.
Okay. So hopefully that gets our, no, don't want that. Back to us. Back to us. Still doing that wrong, Jimmy. We'll get back to just seeing us. Thank you for doing that. We'll get back to us without having the screen grab in there. Okay. So we've heard a little bit about Fei-Fei Li's background. And now we've heard a better definition of spatial intelligence. So now I'd love to now that everybody's sort of like started on this, let's kind of dive in a little bit more. And I don't know, Andy, I feel like I want to jump to you first on this one to get, some of your wonderful summaries and backgrounds of sort of where this comes from. So when this topic came up and you knew this show was going to come up, where did you sort of dive into this?
Yeah, thanks. My interest is in comparing the development of human intelligence from infancy to the development of artificial intelligence. And so let's just be clear that what we're working with now, largely in large language models, is a very verbal and cerebral cognitive kind of thing. The foundation of human learning is not verbal cognition. It's spatial perception. So we have an infant on our property for the last year, now 11 months old. And so when you watch a baby doing things, it's not reacting to your words at all. It's in space. It's seeing things. It's feeling things. It touches things and gets texture, and it feels shape, weight. And those sensory experiences are building that deep neural network that the human brain is, with an understanding of what space is before they ever think about a word. So as they watch and they move and push and pull, they're getting some idea about spatial relationships, like that toy's too far away to reach, right? Object permanence. Just yesterday, my grandson was on all fours crawling around a box, and he was just in a high energy mood, and he would crawl around behind the box and stop with his head just short of revealing it around the side, and I'd wait, and then he'd poke his head out, and we'd both squeal, right, with joy, just understanding that objects are permanent. Like, he gets that when he goes around behind the box, he's not visible and I'm not visible, but we still both exist.
Right.
That's a part of spatial intelligence. And then finally, how to predict how objects move and interact with each other. And that's like understanding Newtonian physics. So Fei-Fei Li's in physics. So getting that mass and motion work together is really important. So one of the games that we play is, we have a big playroom, and I'll take a little car and it has a motor in it. I turn it on and it starts going toward him. Well, he's fascinated by this thing coming toward him, but it takes time for it to arrive to him. So he's developing this concept of objects moving in space over time, just as was explained in that clip. Much, much later, he'll start to piece this together in the context of words and sounds. But the initial and foundational learning that a human goes through is spatial intelligence. All of those different components, perceiving things, reasoning about what will actually likely happen, and then figuring out how to do their own planning about how to maneuver. And he's already at that stage, by the way. He knows how to, decide what the best path is, crawling and or, scooting to get to a new position that he wants to get into. So that's my area of fascination, is this comparability between what's happening in real human intelligence as we try to approximate that with artificial general intelligence. Many are saying, Fei-Fei Li among them, that spatial intelligence is essential to getting to artificial general intelligence.
Yeah, well, I mean, I love the analogies and the explanations of your grandson, because what a great visual of thinking about an 11-month-old crawling and hiding behind a box. And to your point, at 6 months old, you quite literally disappeared. That's why Peekaboo works with babies, because to their knowledge, you literally disappeared and reappeared in space, right? And now he's getting the concept of you're still behind the box or whatever. In time, he'll even be able to watch a movie or watch a video and understand spatial recognition of that video, which they also talk about on here. And I think that's another step to it, which is that if you saw me right now turn around very quickly and look at that plant, even if it freeze framed right now, all three of you could fill in what might happen after that. The plant is falling over, something knocked it over. What would happen? You can fill in all the rest of that. The plant falls over, it probably knocks some dirt on the floor. What caused the plant to knock over? What else is happening? Could I roll back my chair without hitting it? How far back away is this in the room? So we're able to take this 2D representation, and with our neural networks, the way I understand them talking about it is we can infer, we can make certain predictions about how the world works because we live in this 3D world. And so what they're talking about is, hey, yeah, you're right. Language comes next. And Fei-Fei Li in her TED Talk talks exactly about that. There was sight and light long before humans had the ability to do it. We weren't around to observe it, but at these microorganisms and things like that first had the ability to look at light. She sort of talks about this evolution. And so then she says, okay, look, that's what we're trying to apply with AI. And although language models are a great place to jump off of, and neural networks and what they were able to do with transformers, there's a lot to be gained from it, but it's not the same thing. It is incredibly hard to understand and conceptualize these models that have to understand 3D. And that's something that they're working towards, because to your point, Andy, it's very, very important for the future of it. We can obviously just plug in robots and find out right away that robots need to have a spatial intelligence in order to be very, very effective in our 3D world. And we've talked about that before. Or let me jump over to, I love that, by the way, Andy. Let me jump over to Beth or Jimmy. What was as you guys sort of dove into this topic, what was sort of some of the first things you brought back from it?
Well, I would say it's a great insight on some of the new or future steps that we can imagine for spatial intelligence. It's certainly not a new concept. We've just been seeing pieces in different aspects, or not taken within a holistic context, right? So when we talk about things about AR or VR or XR, these are all terms that have developed from whatever their unique application or specific application. So the concept of the meta glasses and things like that, where we have an overlay of our experience in our spatial world with additional information on top of it, right? That's an example of AR. That's still spatial intelligence, but just from that context. In VR, very popular method of experience VR is virtual worlds and video games and things like that. So everyone's pretty much had that experience on some level, where you are doing world building and how your avatar, or your experience in that world is, what you experience, how you experience, and even who you talk to and interact with and things like that. And then on top of that all of that's wrapped up into to XR. That's an experiential reality here. So it's like, and how you interact with everything there. So I think all of these different aspects, everyone is kind of familiar with what spatial intelligence is, but I don't think it's really been talked about until recently, how all of that is collectively part of spatial intelligence. And if you go look at the World Labs site, and they like you said, it's only been around for like a month or so,
right?
Or at least launched. And they talk about what their main purpose is, and that is to build large world models, right? And we've heard this term before from companies like Runway. And the concept is to essentially build models that can interpret all of those various data points, and spatial information to really have a real sense of how physics works, how things are going to move, how things are going to react, and all those kinds of things to create a more deep understanding of a world, or create a more deeper virtual world, and those kinds of things, right? And so what are these major benefits? Well, number one, they allow us to explore questions of our own world, but in a virtual world. So that means we can input probable or possible data points like weather forecasting and things like that to give us, geological probabilities and predictive analysis. We can see maybe we can fast forward maybe the probable effects of, if we did X, how is that going to affect the environment? How is that going to affect this region? And even at business levels where it comes down to, oh, you should build your store here because it's got better foot traffic than, traditionally in another place. So there's a lot of different layers that how this will be beneficial. I think what's coming to the forefront of most people's minds right now is, like you said, Brian, spatial intelligence is going to be a key component for everything surrounding embodied AI, robotics, and that kind of field. And so it's a crucial piece of how we will get a really effective and hopefully excellent experience as those technologies develop.
And that's why I think it's important to, what you were just saying, Jimmy, it's important to reemphasize that this is not a direct path from large language models or multimodal models, which were built, even multimodal models were still built on this idea of static, or this, as Justin Johnson refers to, this is not me, but him saying 1D, one dimensional. And that there's a lot to be gained from the neural networks and the large language models as far as knowledge and compute and just the fact that there's probably a lot more money. I mean, hell, World Labs is a month old, but they basically came into existence with over $200 million in investment because of their four main co-founders, of which Justin Johnson and Fei-Fei Li are two of them on their team. And I feel like I do want to at least, it's on their website. Hold on. I feel like I want to at least name the other two people. Justin Johnson is the second one, Christoph Lassner and Ben Mildenhall. Just want to give credit where credit's due. Those are the four co-founders of this. They have $250 million, which by AI standards is a drop in the bucket. They might as well have gotten $5 outside of Publix, but it's still to the point that there's more in this. And Fei-Fei Li talks about this as well. Like, they were in the winter of AI for so long, but she knew that this was going to be important. And she had actually was focused on, from what I understand, into images and pixels. And then she has this really great point, basically with stable diffusion and reversing the images, as Andy, you explained to us before, and how those models sort of work together to go backwards from pixels to an image, to recreate an image from text to image. And she talks about how she thought that's where her focus was going to be. But then her North Star sort of changed as they were able to achieve that going backwards, meaning the diffusion part of it, in a year's or 2 years' time. And she thought it might take 10 to 100. She's a godmother she's widely considered to be a godmother of AI. Much more in this, done PhDs, was a VP at Google, among many, many other things that she's done already, and Stanford and things like that. And even she was really thrown by how quickly others like Justin Johnson and Andrew Karpathy were able to achieve some of these early papers. Justin Johnson has a good quote in there talking about, in the early days, his favorite thing to do was like Christmas Day, but he felt like the academic community was the only person that got to do it, which is you went to the archive site and there was a new paper and it was like Christmas with new packages that you got to open. And he said, now in the last 2 years, I feel like everybody is getting that with AI. It's every day is Christmas. Every day there's a new package to unwrap, a new paper to see, a new study to be done, new money put into it, which is really, really exciting. Okay, Beth, we have not heard from you. So before I talk more on this, I'd love to get your thoughts on this.
Well, I just want to capitalize on one of the things that you just said. Quick promo for the show. One of the reasons that we have value in people's lives is because we're opening all the packages, which can feel really overwhelming if you're coming downstairs to 50 new presents every day. Come back, because that's what we do. The other piece that I want to bring up is Justin's comment in the chat, and if you're listening to this, come join us in the YouTube chat because we're having a great time here. Do you think spatial understanding in AI is an emergent property, right? Because so much of what we understand in terms of language models, large language models, were emergent properties, because Fei-Fei Li is not the only one who thought it was going to take much longer. So did the people who put together, so did OpenAI, right? Like part of the reason OpenAI is structured the way it is because they did not know how it was going to emerge and when and that kind of stuff. So in answer to that, in terms of Justin's comment, and he answered himself at the end as well, we're now talking about different kinds of data in the way that Andy was referring to, right? So and Jan LeCun has been saying this forever, language models are not going to get us to a world model, to an understanding of how things in the world work, because text descriptions of how things in the world work is not enough to anchor that in a way that allows for emergent property. So now the next question is, what is the data needed in order to build that? And if you were with us yesterday, we talked about Tesla cars driving around are basically data collection units for how things move around in space and like that data. So those are my thoughts.
Yeah, let me thread off of that and mention on the technical side, there's a need to go toward a more advanced kind of reasoning that incorporates not just some predictive capability to determine what the best path is, but also what is technically being referred to as neurosymbolic reasoning, which is adding symbolic knowledge and logical rules about how those symbols work with each other. That enables a model to reason about abstract concepts, relationships, and sequences of actions. So neurosymbolic reasoning is really the objective of these initiatives that Fei-Fei Li is going toward. And this gets to another point, which Jude mentioned in the chat. How is AI going to learn about three-dimensional space from video that's largely two-dimensional? And there's an answer to that. There are special routines that are built in AI that can take a two-dimensional image and create a three-dimensional model out of that very, very successfully. And then it works with the 3D model. So it can take examples from movies, create a three-dimensional model out of it, and then reason about that model or learn from that model and all the things that are happening. Oh, heaven forbid that they use, fascinating, fictional movies, though, to do that. We really want them to be grounded in the real world and what really happens, not what some, Hollywood Imagineer considered to be, exciting. So there's a lot of development that has to happen, and a lot of it has to do with reasoning and the advancements of reasoning. And that's part of the progression that OpenAI has described with respect to the approximation of artificial general intelligence. And it's adding symbols in order to abstract concepts and visual symbols, even how to manipulate and interpret and reason about visual symbols, and logical rules as are driven by Newtonian physics. Like, you can't run this vehicle into that wall and have it bounce back. It's not going to do that, right? Because there's issues that you have to understand in terms of the logic of how mass and motion work. So that's complex math. Yeah, I'm glad there are research scientists out there handling it. I'm an old English major and skier, so I don't grok these things in the deepest way, but I'm glad there are people like Fei-Fei Li and her cohort there working on these things at the most advanced levels.
Yeah, Justin Johnson actually talks about just what you just said, Andy, about this being almost like a math problem or a math solution, as a lot in our 3D world can be, right? It's a lot of physics, as Fei-Fei Li came from, and mathematics. And so we've already seen this. In fact, Fei-Fei Li references this and says her students created a rudimentary example of this like a couple of years ago, where you can take I'm trying to find something here, my remote here. You could take a picture of this remote, and they have the ability now to create a 3D model that will actually rotate around this remote, despite the fact that the original picture never showed the backside. Now, is it going to be 100% perfect? If there was a sticker on the back of this that said Brian Messeri on the back of it, would it have predicted that? No, but can it reasonably figure out what a rotating, remote looks like from a static image? That's something that already exists. And I want to bring this to the bigger point that Justin makes on there. And then I have another clip that I wanted to share because he explains this much, much better than I could. But this is something that really hit home for me. He said, we started with object, meaning, he says in the video here, there's a table, there's a chair, there's a microphone, there's a whatever. And then we're moving to scene building. Okay, I'm in a room, there's a scene, there's a desk, there's a whole thing going on. And the idea that AI understands what is happening in the scene. He said, we're going to world building. Now you can move anywhere in any direction in that scene of multiple scenes. And eventually, they even talk about this, could you go to the book on the desk in the virtual world and open the book and there would in fact be pages and words there? And he kind of laughed and he said, well, I think eventually, yes, you'll be able to dive in and go in any direction you want in these virtual spaces, these virtual worlds. But we're moving from object where we are today. We're already seeing this in games because they reference that and say that's where the money is, right? Because you can invest money into gaming. And so that's why we see these really complex games and virtual worlds in there. But eventually it will move out of that. It'll get to a price point, as he explains, that will be so cost effective that it'll reach education and it'll reach medical and it'll reach all these other places, whether that's, virtual reality, a virtual, simulation, or perhaps AR, back to what you were saying, Jimmy, because he made the point, and it's a good one. This is a very cool, obviously, I've already said I like this interview. Go watch the interview because I'm high level here. But one of the things he talks about is, right now we have different screens that do different things. We have our iWatch, our phone, the screen I'm looking at you guys on now, bigger screens, movie theaters, or whatever. He said, if you understand spatial intelligence and you get to the point where it can overlay in your real world, that's no longer necessary. You don't have to create screens that solve for these problems. It's overlaid appropriately in your real 3D represented world. And once we're able to achieve that, it greatly changes how we're able to consume information. Do you need to? I have 2 monitors on my desk right now. Is that necessary? Perhaps not in the future, whether that's contact lenses or meta glasses or whatever that is. I might just sit at this desk and you guys may all be on virtual screens that I can pinch, and just like you can with the Apple Vision Pro, only not with goggles on, right? So really, really interesting stuff. But I love this idea. I want to say it again, from object to scene to world building. That it helps, right? Because then you're like, oh, okay. Okay, we're not talking about 3D representations of remotes anymore. We're talking about 3D representations of my whole room, my whole house, my whole community, my whole world. That's a big deal.
Right. And the other piece of that is sequence. And sequence stands out for me because that's a place that my brain doesn't do easily. I can see the puzzle. I can see how the pieces fit together. But the sequence of what should happen first, Obviously, there are 1,000 things that can happen first, but like a clear, easy path that is not just like, hey, you have all the puzzle pieces. Do something with them because they make a puzzle. I really think that the other interesting thing about this is the way that the big companies have implemented and started to find like individual ways of expressing the data. So we've seen depth perception models, right? So you can take it can take an image and then it does sort of a heat map of what's forward and what's behind.
Mm-hmm.
The first time I saw that was I think ByteDance. There are, I'm sure other people have done it, but that was a big thing that ByteDance put forward. And they're the people behind TikTok. Meta has segment anything, which means you can focus on one particular object in a video, and that will remain the focus, right? So it tracks how that moves in things. And now the world building, being able to take something, develop a 3D idea behind it, and then spin around in it, right? Or move forward in it, or any of those sorts of things. Those are fascinating concepts, and also really interesting to see the different ways of expressing it that creates different values, right? Like depending on where you want to go with this tech, you're going to lean in one direction or another. Junmi, what do you think?
I think we're going to see some fantastic examples coming out really soon. In that podcast, they had mentioned you could wear your glasses and a AR display would come over and help you fix your car engine.
Mm-hmm.
So, just that concept of instant access to information and tutorial and education. So that gives a more sense of empowerment and be able to accomplish more things in your world, your real world, just with that extra layer. Now that can translate to even further development and research into, like Brian, you had laid out, object, scene, world, universe, right? So if we have enough data, if we have enough points of reference, then we can really model out, what is the most likely scenario with these factors, right? And I'm really excited about that kind of thing. I'm sure we'll see it in the entertainment side first, just because that's the easy transition for them, right? More immersive experiences. But I think in a larger sense, it kind of hits every single field. Is what the way we do things now is it's tests, right? Like in science, it's like, oh, hey, I want to do, a bunch of labs, or I want to, test for this molecule or put these combinations together. That takes time. With AI, what we've been seeing big jumps forward is accomplishing many thousands of iterations of the mundane tests. But I think this will take it that one step forward where it's no longer just, oh, I'm just doing the mundane. Can I create a simulation with enough information about the world, the large world model, where I can accomplish development and invention of new things, because time is now a variable factor, right? I can speed things up. I can run things like, oh no, in 100 years, what would this material do, right? Yeah. 200 years, right? Those kinds of things. Can we see societal analysis? All right, well, these are the expected, implementations or data or, outside forces. How is that going to look to progress? So a lot of the field is wide open, and when you have a full virtual world or full simulated world, then you can. I think it's that leap. You'll see a leap in that kind of development and in research and things like that. That's what I'm looking forward to.
Yeah, in one word we haven't really said, but we've certainly talked about on the show, is synthetic data, right? Which is going beyond whatever we currently have on the internet, all the stuff we can scrape and whatever. But in the future, which is now, I mean, as far as AI and I'm sure in spatial intelligence, they'll be working with made up data, synthetic data that isn't representative of some physical thing in the world, but similar enough that they can run iterations, tests on, or whatever. And I love the idea because you mentioned it. I think it was Feipei Li who mentions the car. But yeah, like the future of YouTube, right? I was just saying, I think this yesterday. I think I sent it to you guys that I wanted to do a small brake job on the Chevy Bolt, and I was able to find videos on YouTube that got me really, really close enough that I was said, I can do this because I've worked a little bit on cars in the past, but it's been a few years. Certainly seen within my wheelhouse. When it comes to automotive and electrical, I'm usually like, there's a point where I go, nope, leave that to the experts. Don't touch that, right? But this was in my wheelhouse. I felt like I could do it. Now, I watched some YouTube videos. Now, for me, the next logical step is leave the 2D representation of watching somebody else do it. Now, I couldn't see behind the brake pad. Maybe it didn't have my perfect angle or whatever, but I got enough of it to say, I think I can go out in my garage, use the hydraulic lift, pinch the tires, and I can grease this caliper piston, which is what I need to do on it, right? The future, though, with spatial intelligence and what we're doing is maybe watching that initial video, followed quickly by okay, Brian, put on your artificial or your AR glasses, right? And you're going to simulate going through the process. And in my field of vision, it's got like a 3D representation or hologram, if you will, in front of me that says, okay, now which one did they say the caliper is? It's the yellow one. Yep, that's the part, whatever. What bolt would you take out first? It said to take out the first bolt. Now, I might go through it 2 or 3 times sitting at my desk like this. And then it may say, I think you're ready. You want to go out to the garage and tackle this project? We can do it together. And now I go out there and now looking at my actual brakes on my car, it's overlaying the information that I was able to take in as the human and now do the work. Now, some future version of this is probably some Optimus robot sitting next to me who I have to keep slapping the hand and go, let me do it. Let me do it. I know how to do it. And the robot's like, this one, you're like, stop it. Don't show me. Like I want to learn this for myself. And the robot's sitting there going, just let me do it. I can do it in 30 seconds. Just let me do it. So there's some future element of this where we will be fighting back against the robots to let us do things simply because we want to. And the robots will understand the idea of a human wanting to accomplish something that could be accomplished for them simply because humans want to put their hands on it to do it. And that'll always be the case. People always want to tinker on an engine or whatever that is, right? So anyway, I just want to see that expand, like where this is going. What does YouTube look like in the future? Not just us looking at it on screen. It'll move from information to education to virtual hands-on to literal hands-on. And I think we'll see that some senses of that in some industries in the next 10 years. And I might be way overshooting that. It might be in the next 5.
That's true. That's true. I can't wait until I can repair every single device that I own. And I can't wait until I have an overlay of like my hands doing the actual thing, like you talked about, like taking off a nut or something like that.
Yeah.
I can literally just have the AR showing me the hand movement, and I just make the same hand movement as that's happening in AR, and replace something or put in the new part or anything like that. I love that.
We've kind of already seen it with playing instruments, right? Playing piano, the overlay of a piano. Where's your hand position? Typing, same thing. I remember being in high school and I was right at the end where I was still learning on a electric typewriter, not a computer. I think quite literally the next year they brought in the Apple IIe's and everybody was typing on Macintoshes. But for that one year, that last year, I was still doing the hum of the electric typewriter, click, 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 click. And all I remember from that is my teacher telling me I was hitting the C key with the wrong finger. It's supposed to be the pinky, and I kept using my index finger or something, my ring finger rather, on my left hand. And I remember just basically, verbally getting slapped on the knuckles over and over and over because I was using the wrong finger for it. And I thought, what does it matter? It's just typing, right? Well, you can imagine in a future where people are learning to type or these skills, playing an instrument, fixing cars, whatever, the medical, obviously, and doctors and everything else. And like you said, having an overlay that helps you correct your positioning. Shooting a basketball and keeping your elbow in instead of shooting like this, right? You know, you don't see Steph Curry shoot basketballs like this. His elbow is always here, it's always here, and it's always the same. You know, Clayton Clark, same thing. There's a rhythm to it. So I can see a lot of spatial intelligence type solutions where people are able to learn either for enjoyment and fun or for new journeys and, you know, jobs and, you know, those kind of things as well. I didn't get a chance to do it. I mean, we could talk more on this, or I can play this clip. I did have one more clip set up. It's just shy of a minute and a half. It is, sorry, I just forgot his name. Give me a second. Justin Johnson, the other person on the thing. And this is where he talks about the 1D to 3D. And I just found that really fascinating. Do you guys want me to cue that up, or do we want to keep talking? Yeah, Andy says, okay. All right. But Jimmy, I need you to help me bring it back on the screen because I don't know how to do it. How do I bring the screen back? If I say share this tab, yeah. Okay. After the show, you're going to have to show me how you're doing that. Okay. Let me play this clip really quick. Like I said, it's about a little over a minute.
Language models that we're seeing nowadays, their underlying representation under the hood is a one-dimensional representation.
Yeah.
We talk about context lengths, we talk about transformers, we talk about sequences,
Attention.
Yeah. Fundamentally, their representation of the world is one-dimensional. So these things fundamentally operate on a one-dimensional sequence of tokens. So this is a very natural representation when you're talking about language, because written text is a one-dimensional sequence of discrete letters. So that kind of underlying representation is the thing that led to LLMs. And now the multimodal LLMs that we're seeing now, you kind of end up shoehorning the other modalities into this underlying representation of a 1D sequence of tokens. Now, when we move to spatial intelligence, it's kind of going the other way, where we're saying that the three-dimensional nature of the world should be front and center in the representation. So at an algorithmic perspective, that opens up the door for us to process data in different ways, to get different kinds of outputs out of it, and to tackle slightly different problems. So even at a course level, you kind of look at outside and you say, oh, multimodal LLMs can look at images too. Well, they can, but I think that they don't have that fundamental 3D representation at the heart of their approaches.
Okay, so really cool, right? Really cool to listen to him speak. I mean, it's so fascinating to listen to people who are just so highly intelligent and been in these fields for so long, whether it's Fei-Fei or Justin or so many other people that we've researched and listened to on this show. It's really evident to hear somebody take something that's very complex. You get a sense that they have a really good understanding. These are people we should be listening to. They're the experts in the field because they're able to distill something that's inherently complex. And it emitted in 20 seconds. He's able to go, oh, yeah, no, I get that. I get how that's different from an LLM. And he's saying, conceptually, we need to be thinking about this from a 3D viewpoint, not from a 1D trying to get the 3D. The data going in should be 3D, and we should be building from there. That's spatial intelligence. That's what we're hoping to achieve. That's that object to scene to world building. Go ahead, Beth.
Right. And we know that the ways that large language models conceive of the relationships between the tokens is 3D, right? It is actually based on on the neural network the nodes being placed closer or further apart, which determines how creative, what we talk about is how creative the model is able to be. If it's not creative, it always picks the nodes that's right around it, right? That is a 3D concept of this language. So yeah, I'm super interested to see how this relates and starts emerging, because then does the system already exist? It's just that the data that's being fed into it is maybe its own little 3D model, right? So it's a holographic kind of thing or a macro, micro kind of idea. Yeah. Oh,
I know, right?
This has been exciting.
Yeah.
Who needs coffee? My brain is like...
Yeah, I know. I've had too much caffeine once again. I got to stop doing that before I get on these shows because I get way too excited. For Andy and Jimmy, it is fundamentally early morning. And for Beth and I, we've been going for a few hours. We're 3 hours ahead. So when I hit the show, it's 10 a.m. and I've had a lot going for me. And then, Jimmy and Andy are West Coast. So Carl and stuff like that. So it's a different morning. We always see Andy's sunrise, which is one of my favorite things, is Andy starts in the dark and ends in the sunlight, which is a perfect analogy for this show, that we start in the dark with a concept of spatial intelligence, something that maybe none of us knew about before today. But by the time the show ends, our goal, our hope is that you're sitting in the light just a little bit more. The sunrise has come up just a little bit more, and you have a little bit better understanding. And all of us hope, as Beth said, we're playing Santa here. All we want to do is put more fun presents under the tree. And those presents are intelligence. Those presents are information, knowledge gaining. We get excited about it. And that's our goal, is to just keep bringing more presents for people to unwrap. And then to jump from this show, where hopefully everybody in the comments or anybody watching this is sort of as excited about spatial intelligence as we are researching this, and then goes and watches this 45 or 48 minute deep dive where you can learn so much more because we just hit the top, or go watch Feifei's TED Talk, or go to World Labs, which, by the way, is probably .com, but no, excuse me, it's not. It's worldlabs.ai. I'm glad I double checked that. Not a lot on that page, and they actually say for the most updates, you should go to either their X page or their LinkedIn page. I checked both of those, and there's only been about 5 posts in the last month. Like I said, September 13th, a month and 2 days ago, was literally their Hello World, where World Labs post. So when I tell you their company is very new, I am sure we will be talking about them over and over again, and what comes out of their ideas on that show. So with that, we'll probably wrap this one up. I do want to throw up, nope, this one, maybe both. Still learning, Jimmy, still learning. But click one of those UR codes. I think maybe this one's the right one on the right-hand side. That will take you to our website, but it'll also help you sign up for our newsletter, where you can get more information like this, more deep dives. It happens once a week on Sundays. The last one just went out. It was edition number 19. So sign up so you can get number 20 and get it delivered to your inbox on Sunday mornings at 8 a.m. Eastern, because that's when they go out. You can also learn more about our website there and the show. And our co-host, Aaron, is actually doing some stuff on the back end and really going to upgrade the website. So stay tuned for that. It's fairly simplistic right now. We just wanted to get something going a couple months ago, but Aaron's doing us a solid and getting that thing rocking and rolling. Okay, we're going to wrap it up there. I'm going to try to get to all the places I need to and all the pieces I need to wrap the show up correctly. But thanks for hanging out with us. Thank you for all the comments as well. There's some really good ones. I did want to call out, I think Jude said that this is really going to revolutionize recycling, which you have to be with the show a little longer to know that that's an inside joke with Carl, because all Carl wants is for AI to solve his recycling needs and take out the recycling to the curb. So I love that there was like a bit of an inside joke. That just means our crew, our people in the comments you're our people. We love you. Thank you for being there. With that, we'll wrap it up. Tomorrow we'll be talking about the news, all sorts of fun things in the news again. Google's getting into the nuclear space. We'll talk about that tomorrow. Until then, guys, have a great day. Bye.
Aloha.